Okay, today we're going to talk about scatter plots. And scatter plots is when you're comparing two sets of data on one graph. And we're essentially going to graph one set of data, okay, along the x-axis on the bottom and the other along the y-axis. And the point where they meet is going to be our plot or our dot. So for example, okay, this one, we're going to talk about positive correlation first. Okay, if this person had a height of 60 inches, which is 5 feet tall, and then a shoe size of 8. Okay, so I'm going to come down here. This is where the height would be 60 and the shoe size is 8. So where they meet, okay, this means a 60-inch person had a size 8 shoe, and I'm going to put a dot there. Okay, then let's look at our next data point. I'm trying to cram this all in here. Okay, our next one is the person is 64 inches tall and they wear a size 9 shoe. So I'm going to put a dot right there. Right, so I've done this one and this one. The next one, the person is 62 inches tall and they wear an 8.5. Then I have someone who is 72 inches tall and wears a 12. So my numbers got a little bit off here. This should be 68 on this line, and then 70, and then 72 would be right over here. And they wear a size 12. Okay, then we have someone who's 70 inches and they wear a 12. Someone who's 71, so that's going to come in between 70 and 72, and they wear a size 13. The next person was 61 inches, so in between 60 and 62, and they wear an 8.5, so in between 8 and 9. Then we have someone who's 75. Oh, you know what? We're going to skip that one because I didn't make my graph go that far. Okay, then I have someone who's 70 who wears a size 11, 68 and wears a 10, 68 and wears a 10.5, 70 and wears an 11.5 in between 11 and 12, 60 and wears a 12, and then 72 and wears a 9.5. Oops, that's 8.5. Here's 9.5 right there. Okay, so what we're looking at is in general, okay, what do you notice about these dots? What do you notice? In general, okay, this is what's called a positive correlation. Okay, as our height increased, so did our shoe size, right? So as the X increased, so did the Y. Okay, there are always going to be anomalies, okay, like outliers. Like this person was 60 inches tall and had a really large shoe size. This person right here was pretty tall, but didn't have a large shoe size. So it's not always going to be exact, you know, there's no way I can draw an exact line through this. But in general, as X increased, so did Y, and that's called positive correlation. Okay, another example would be like as, I'm trying to think of an example, like as the minutes that you run increase, so do the calories that you're burning, right? Or the steps you're taking. If you're wearing a watch that keeps track of your steps, the longer you're running, the more steps you have. Okay, as the hours that you work increases, so does your paycheck, right? If this was how many hours you're working and this is how much your check was for, in general, the more you work, the more you get paid. Let's talk about negative correlation, okay? On this graph, we're going to graph the number of hours that people are spending on YouTube the night before a test, okay, watching YouTube videos, and we're going to plot it against their math test grade the next day. So let's look at this first person. Okay, they studied, oh, I lost my pen. Here we go. They watched 2 hours of YouTube and they made a 90 on the test. Okay, the next person watched 0 hours of YouTube and made a 95 on the test. The next person, the night before the test, watched 7 hours of YouTube and made a 60. So that would be right down here. Okay, I'm there. The next person watched 3 hours, made an 85, then 5 hours and made a 70. Then this person watched 0 hours, made a 75, 1 hour, 85, 2 hours, 95, 4 hours and a 70, 6 hours and an 85, 4 hours and an 80, 3.5 hours and an 80, half an hour, right, in between 0 and 1, and they made a 100, and then 2.5 hours, and they made an 80. Okay, so we're going to kind of ignore some of these outliers, and what trend is our data displaying? This is a negative correlation or a negative trend, right? Again, there's outliers. You have someone who didn't watch any YouTube and, made a 75, and then you had someone who watched a ton of YouTube and made an 85. But in general, as the hours increased, the test scores decreased. Okay, that's a negative correlation. As my hours online shopping increases, my bank balance decreases. Okay, negative correlation, as one thing increases, the other decreases. As your height increases, the number of times you can go under a limbo bar at a luau would decrease, right? Someone whose height was 60 inches might go under 10 times. Someone who was 7 feet tall might go under 1 time. Okay, in general, this is called a negative correlation. As one data item increased, the other decreased. And then the last thing we have to talk about, spoiler alert, it says it on the top, is no correlation. Okay, we're going to plot this data, which is your birth month, so like January, March, February, okay, with how many siblings these people had. So let's look at this first one. Okay, they were born in month 1 and have 0 siblings. So month 1, 0 siblings. The next person was born in month 3 and had 5. The next person, month 2, 3 siblings. The next person, month 2 and 1 sibling. 4 and 0. 5 and 2. 7 and 4. 6 and 1. Oops, that's not 1, this is 1. 5 and 6. 4 and 1. 4 and 2. 6 and 2. 5 and 4. And then 1 and 2. Okay, is there any trend to this data? There is not. I can't draw a positive or a negative correlation because these two things have nothing to do with each other. Okay, so the cool thing about scatter plots, in general, the trend's going to be pretty obvious. The more data you graph, the more obvious the correlation's going to become, right? If I graphed 1,000 people's data, it's going to be everywhere. It's going to be so obvious that there's no correlation. Okay, same thing here. If I surveyed 500 kids and plotted their data, this correlation would get even stronger.